This is the IBM Systems Application Architecture Videodisc course. Welcome to the IBM Systems Application Architecture Videodisc course. Touch a box of your choice.
This course provides marketing information and education on IBM Systems Application Architecture. Systems Application Architecture, or SAA as it's called, is a collection of conventions, guidelines and protocols which cover various aspects of software interfaces. SAA is becoming the framework for developing consistent applications across the major IBM environments, including OS/2 Extended Edition, OS 400, and System 370 VM-SP, VM-XA, and MVS-ESA. SAA has been developed by IBM to provide a software bridge between computer architectures. SAA has the power to make significant improvements in applications management, the power to provide solutions. It brings benefits in three important and closely linked areas: productivity, flexibility, and consistency. The level of consistency offered by SAA brings a number of major benefits to the end user. It brings consistency of interaction techniques and of screen and keyboard layouts to an entire enterprise. Ease of use and end user view consistency are greatly improved. SAA's common programming tools, languages and services are consistent for different operating systems. With this consistency, a program can be moved from one IBM system to another with no or minimal changes.
Data processing specialists now demand uniformity from applications.
Application solutions are made easier to learn and to use. They can be developed more quickly and can be implemented across the product line. SAA provides connectivity across different operating systems. Obstacles to data distribution are removed. Unity is now possible throughout the IBM product line. Total consistency, and therefore total interconnection throughout an entire enterprise, becomes an achievable goal.
Whether they are different applications on the same system or the same applications across different...
The flexibility provided by SAA brings a number of major benefits to the end user. Computing systems can easily communicate and share resources. Programming skills are easily transferred to a wide range of hardware and software solutions, making application development more flexible and efficient. SAA is applicable to computers both large and small across an entire network. It brings the goal of distributed processing within easier reach than ever before. SAA has the flexibility to meet any business challenge. A customer can protect the investment he has already made in a different strategic computing platform because SAA allows integration with existing systems such as AIX. SAA is an architecture that can be extended and developed. SAA software is moving forward in a continuous fashion to exploit the changing power of the hardware. SAA can bring the customer significant gains in productivity. SAA enables the development of cooperative applications which exploit the power of the workstation to provide a genuinely user-friendly interface, together with the power of the host processors to store and process data. The graphics and responsiveness of a workstation can be combined with the data and computational resources of the host. An excellent example of this concept of cooperative processing is IBM's Office Vision, which uses the PS2, running OS/2 Extended Edition as the workstation, with either the PS2, AS400 or 3090 as the server providing mailboxes, calendars, etc. Cooperative processing delivers significantly greater productivity from computer systems. It positions SAA to be the basis of the development of systems in the future. IBM is providing this environment to allow cooperation between the workstation and the host. SAA leads to a more productive use of human resources. Standardized programming and end-user view leads to greater productivity from professional programmers. Application designers become more productive. An application can be transferred with little or no change throughout the enterprise. The demand for application solutions can more easily be met. Consistent user interface across applications means that staff are mobile and can move freely between departments. SAA facilitates the restructuring of staff responsibilities. SAA allows the maximum productive use of computer hardware. Communication is improved because user interface is common to all personnel, from management to secretarial staff. Less time is spent in the training of new personnel. Throughput is improved and errors are minimized. Productivity gains accrue through the greater efficiency with which SAA can bring to business tasks. Faster preparation of budgets and reports. Faster distribution and analysis of data. The streamlining of information access. SAA offers a wide range of quantifiable benefits in flexibility, consistency, and increased productivity. Those benefits, together with the opportunities provided by the concept of cooperative processing, mean that SAA is positioned to be the basis of the development of systems in the future. To all of IBM's customers, both large and small, SAA offers an excellent investment strategy for the future.
Let's look at a specific example using the IBM systems can be classed as small, mid-range, or large, based on different computer architectures. Broadly speaking, large systems are based on ES370 architecture. Mid-range systems include AS400, and the most common type of small system is the Personal System 2. IBM has developed these hardware families with corresponding operating systems to meet different user requirements. There is some overlap between the three families in terms of their size. The two operating systems used for large systems are MVS and VM. The mid-range systems include OS400, and the Personal System 2 runs OS2 Extended Edition. One of the objectives of IBM Systems Application Architecture, or SAA, is to provide a common framework for software development, encompassing these three hardware families. It allows systems of different sizes and architectures to be combined in a common applications environment. This increases the productivity of the software developer and makes it easier for users in specialist fields to work with different applications. Let's look at an example of this. Applications developers develop a program in a System 370 mainframe environment and use a language compiler specific to that environment to create a program which runs under the MVS operating system. When the developer wants to run the application on the AS400, this will be much easier if the program will move across with virtually no modification. So the source code developed and used on the System 370 must be portable to an AS400 compiler, where it can be used to generate AS400 machine code. The same consideration applies when moving the program onto the personal system too, and it also applies when moving programs upwards from small to large systems. If applications are easy to transport from one system to another, they are much more widely useful. This is a fundamental concept of IBM Systems Application Architecture. The motto is, develop once, move wherever you want. Let's look at users of one type of system, the PS2. A newly developed application for this system will be presented to the user with a specific screen layout and specific methods of control. Once the user has learned the new application on the PS2, his productivity will be greater if he can use the same application on another system, the AS400 for example, without having to learn new control methods. It's in the user's interests for applications to be consistent, whichever systems they are running on. The motto is, learn on one system, use on many. Applications are made up from different functions which process different information. Here, the application has three functions: one for text formatting, one for database access, and one for generating graphics. Developing and testing this application would be more productive if it were done on one machine, with the intention to transport the central database function onto a mainframe environment, to take advantage of its large storage capacity and fast processing. This application would still appear as a closed structure to its user, who would benefit from software designed to use the best features of more than one system, increasing potential performance. This is called cooperative processing, and it is the direction in which software development will go throughout the 1990s. So, to summarize, SAA increases productivity because applications development can be reused by transporting it to different types of hardware with almost identical presentation and methods of control. This is because IBM SAA liberates applications from the hardware and operating system on which they were developed. So an investment in software is maximized because applications written to SAA guidelines need little modification, even when the hardware and system software change. SAA means applications can be produced for use throughout a company, in head office, in the regional office or subsidiary, and at the individual workstation, so that they run in the same way and use cooperative processing to get the best from all system families. Consistent applications allow new technology to be introduced with a minimum of disruption. In other words, evolution, not revolution.
Is often a set of headings for groups of related actions.
Historically, two factors have made information processing subject to constant change and innovation: user application needs and technological progress. In response to the diverse needs of business, large and small, IBM has offered different types of hardware tailored to individual areas of use. Applications for each type of hardware are far more useful if, as well as reflecting the needs of users accurately, they are developed and implemented with maximum efficiency. The operating system was invented for this reason. It makes development time more efficient. In this respect, it is an important precursor of SAA. In theory, it's possible to write an application which communicates directly with the hardware on which it runs. But this method is inefficient. Parts of the program which are specific to the hardware would have to be repeated. To prevent this duplication of effort, applications are written for different operating systems which perform the system-specific tasks and rest between application and hardware. Because the operating system is always there, interfacing between application and hardware, it makes optimum use of system-specific functions. An application written for one operating system will run on any hardware which also runs that operating system. This makes the application programmer's job easier, while users benefit from applications which are developed faster in response to their needs.
From the user's point of view,
The applications programmer is also helped by specialized high-level languages and groups of functions or services. Database services provide functions specific to the new breed of relational database. Interactive services allow a user to carry on a dialogue with the system. Presentation services make it easier to present applications to the user by taking advantage of rapidly evolving graphics features. Communications components support intelligent communication between users working on remote workstations. These features make up application support. They support the development and functioning of applications. They are specific to the operating systems. Different but similar services are available on the various system families for programming and running applications. The components of a system, such as applications, application support, communications services, and the operating system, are tuned to fit together by precisely defined interfaces. The operating system makes optimum use of the features specific to an architecture, and applications take advantage of the operating system's application support, the language compiler, database manager, user interface manager, and communications components. However, even now, major differences exist between the interfaces covering different system families. Differences occur mostly where they're closely involved with the features of an individual system. For a company with just one type of system installed, these differences may not seem important. But what if that company's needs change? Even a company with several types of computer systems, all working on separate bodies of information, may need to connect the systems together and exchange information between them. These possibilities must be allowed for when a computer system is chosen and installed. IBM's SNA and OSI form the network architecture not only for connecting remote workstations to a system, but also for connecting different systems together, providing a basis for communication.
Is a communications protocol for applications running on different systems.
And now, systems application architecture completes the picture by allowing applications to be developed which bring different systems together, each carrying out the tasks to which they are best suited.
Functions which allow applications to talk to one another, such as
The computing power offered by IBM now ranges from the PS2 system to the 3090 multiprocessor system. The range has grown and will continue to grow in response to the needs of IBM customers. IBM has now defined an architecture which is common to all applications programming for its ESA 370, AS400 and PS2 systems. This is IBM Systems Application Architecture, or SAA. SAA provides standards for support functions, making the production of applications economically viable. The basis for these support functions is system support, application support, and communication support. System support is a form of hardware resource management. It includes functions for the optimum performance of the hardware, such as efficient access to external devices and memory management. It is hardware-specific. For example, MVS ESA is designed for computers based on ES370 architecture. System support for the PS2 is totally different.
So let's look at the role of SAA in this
Application support is crucial to applications programmers. It provides, for example, problem-oriented languages and applications generators, services for database management, functions for controlling the dialogue between user and application,
are defined as well.
and functions for presenting information on the screen.
They form the foundation for building a company-wide information system.
Communication support
They also
allows
allow
communication
applications
between
to produce
systems of the
distributed
same family
functions
or
and
different
data.
families.
By placing these protocols and services under the
SAA
umbrella of
guidelines
SAA,
embrace different
IBM
products which
has
can all be
demonstrated
used in the
its
same way
commitment to
by
support
users
all
or by
SAA
applications
system
developers.
environments. If you touch one
In
of the
this
symbols,
module,
you
you'll
can
learn
find
what
out more about
SAA
the special
is by
product
looking
groups
individually
available.
at its components.
Now we'll look at how
Common
distributed
User
functions
Access,
and data can be used
CUA,
by application
standardizes the
developers.
elements of an application which a
SAA
user
enables
actually
services
sees.
to be used in a standard
It
way
does
the
this in a
system
uniform
environments it
way
covers,
which transcends different
independently of the
applications
underlying
and,
support
wherever
products or
possible,
hardware
different
involved.
types of workstation.
It therefore defines a standard interface for
Then there is
communication
Common
within the
Communications
framework of
Support,
common programming
CCS.
interfaces. It also
This component
specifies in its
defines
reference manual
selected
that it
protocols
is
on the
possible to use
basis of
calls
systems network
via
architecture,
interfaces to
SNA,
request
and
L6
international
functions.
standards for communication between
So
different
SAA
architectures.
offers a standard method of access to the functions of program
And
to
finally,
program
there is the
communication in
Common
different
Programming
system
Interface
environments.
component, CPI,
Of course,
central to the purpose
SAA
and
products
benefits
which
of
support
SAA.
6.2 must still comply with the defined interfaces.
An application which participates in SAA runs on one of the defined SAA system environments. It uses one of the SAA languages, follows the specifications of the SAA CUA, and in accessing databases makes use of the SAA Structured Query Language SQL database interface. SAA applications must also conform to the SAA Guidelines Communications Interface for communication with other SAA system environments. Now we'll study interfaces in more detail and look at all the SAA system environments. There are interfaces between the layers which enable the layers themselves to interact efficiently with the system through the interface definitions provided. Beyond the scope of an individual system, they are different. For which interface do you think the differences are most critical to the application's programmer?
No,
Touch
that's
the
not the right
interface
one.
you think answers
Try
the question.
another.
That's right. The interface between application programs and application support is most relevant to the application's developer. In order to achieve the objectives of SAA, to increase the user's productivity by making applications appear uniform, to produce portable applications, and to facilitate distribution of functions and data throughout a network, IBM has made it possible for applications programs to be transported to the support products in all SAA system environments by defining a consistent interface. The recommendations for this interface are followed by the application support products for any system environment and by the application's programs themselves. If all applications and application support products follow the guidelines for SAA, it becomes possible to develop the same software for different systems just once, and then to implement it individually with little extra effort. SAA's components are intended to work together to help developers produce applications of a higher quality, which are also easier for users to learn and understand. The efficiency of applications development is also increased by following IBM's application development cycle. This is a framework within which application developers can carry out and monitor the development and maintenance of an application. It is especially designed for the cooperative network applications, which will be the landmark of computing in the 1990s. An interface defines the transfer point between two components in a computer system. The SAA Database Interface, SQL, is already implemented in Database Manager, an integral part of the OS/2 Extended Edition operating system. Database Manager makes use of the input-output routines in the operating system to access a relational database. The Applications program performs database access via the SQL database interface. On the one hand, there's the application, which conforms to the SAA interface rules for accessing relational databases. And on the other hand, there's the Application Support program, which also conforms to the SAA interface rules and performs the required services. There are two interfaces involved here. One is the SAA Database Interface, SQL. This defines the rules which govern interaction between the application and any application support product. The other is specifically for one SAA systems environment, the Personal System 2, with the OS2 operating system. SAA application support products consist logically of two parts: an SAA-specific part, which is the interface to the applications program, and a system-specific part, which is the interface to the operating system. This means that the services required by applications are converted into a format tailored to the operating system. The SAA Database Interface, SQL, is also implemented in other products, for example in IBM Database 2, or DB2, for the MVS system environment. DB2 is designed so that it can use specific features, such as data channels and multiple processors, for physical database access. Touch the part of the DB2 diagram which represents the same function as the Database Manager in OS2 Extended Edition. That's right. The interface to the applications program is the same, the SAA Database Interface. In this example, the interface to the operating system is different. In an MVS system environment, DB2 can use hardware features which do not exist in the OS2 environment. Touch the component which can be taken from the OS2 environment without any modification. That's right. The application is portable from one SAA environment to another. It follows SAA rules for database management. DB2, Database Manager, and the application. Which components comply with the SAA database management?
You're partly right. DB2
Please touch your choices in any order and press Enter when you've finished. Yes. When the application was written, the developer followed SAA standards, as did the software authors who wrote DB2 and Database Manager. SAA frees the developer from concern about application support, system support, and hardware. As a result, any changes made will have no effect on applications development. For example, if a modification is made to Database Manager, this would make no difference to the application because the SAA Database Interface, SQL, remains exactly the same. So far, we've looked at an application which is tailored to the tasks a user needs to perform. But it is also possible to use a standard program for integrating relational databases known as a query manager. Specialist requests for information can easily be constructed using query manager's functions because it still conforms to SAA specifications. Database functions, such as reading and editing, can benefit from the use of a query manager, which must conform to the SAA Guidelines query interface. It also makes sense for database products to use SAA recommendations for accessing rational databases, and of course, to use SAA CUA guidelines when presenting the results of database queries to the user. SAA applications are written to conform to the published guidelines in respect of the communications interface, so that all SAA applications can be easily interconnected. An SAA application follows the rules for support as defined in the reference manuals for common user access. These features are being provided by IBM across all the SAA platforms.
Endlich. Ihre Zeit läuft und Sie trödeln hier. Hm? Aufwachen! Herr Birk. Keuch, keuch. Schluck, schluck. Spuck, spuck. Ja. Verzeihung. Ich komme nicht vor. Nur mal eben so Pause gemacht. Nicht wahr? Also, wenn es hier nicht weitergeht, mach ich mich mal ran. Na? Ist doch klar. Ja. Bei Ihrem Tempo komme ich direkt ins Schwitzen.